everything you need to know about the force of friction, static and kinetic. Friction definitionally is the force that opposes motion. Friction is caused by snagging on a molecular level. Think of those molecule models in the chem lab that you saw last year. Nothing is ever really made of little spheres in this world. Consider what would happen to those two models if you dragged one of them past each other. Balls on sticks would get interlocked, bits would tie up on other bits that all snag, and in order to get something moving, you'd really need to have a good sharp yank with, of course, little wooden balls on sticks flying off to left and right as you yanked them past each other, causing things to break. On the molecular level, everything looks like this. H groups, OH groups, cis, trans, bits are going to get snapped off as you pull things past other things. The smoother and more highly polished a surface has, the less friction it will have. But if you've got two surfaces touching, there's going to be at least a negligible amount of friction. Friction, by definition, opposes motion. Pull on the Velcro, it will pull right back. Friction always pulls opposite to the way you are trying to move. If you try to move forward, the friction will pull back. If you suddenly change directions and try to move backward, the friction will pull forward. If you try to move north, the friction will pull south. If you try to move west, the friction will change direction and pull east. What if you pull the other way? Instantaneously, the force of friction will change. Smart force. True. That's a technical term. Write it down. A smart force is one that instantaneously reacts to what you are doing. Friction is a smart force. There are two kinds of friction. We'll do kinetic friction first because it's simpler and easier. Kinetic friction is the force that slows you down when you're already moving. Push, let go. If you don't go all the way down the hall, through the glass doors into Dr. Schorsch's office, it's because kinetic friction slowed you down. Kinetic friction is the reason you don't keep moving when you're already moving. Now, what does this force depend on? What slows you down? Think of everything you can think of that slows you down when you're already moving. Pause, write down some ideas, press play when you're done. First and foremost, friction is a support force. Lean on a piece of furniture. Go on, put your full weight on it. Did you fall over? No? Well, that was because of the force of friction. The furniture stayed where it was and it supported your weight. Friction is a horizontal support force, unlike the normal force, which is strictly vertical, perpendicular to the surface. So if you don't have any support force, there isn't going to be anything for friction to work with. Friction depends on the support force. What else does friction depend on? Bet you thought of this first. Friction depends on whether you're standing on gravel or sand or slipping on a banana peel. Friction, don't write this down, ought to depend on how rough the surface is, right? All right, so let's take an example. Gravel. You're on gravel wearing boots made out of those hover pucks so that you barely graze the edge of the surface. High friction or low friction? That's too complicated. All right, let's make it simpler. You're wearing good athletic shoes with cleats, brand new tread, tons of friction, unless you're standing on a banana peel on a waxed floor that's just been greased 16 times. All right, maybe that's not such a great example. Maybe friction doesn't depend on how rough or smooth the surface is, but how rough or smooth both surfaces are. All right, that sounds better. Write that one down. The amount of friction you experience depends both what's on your feet and what it is you're standing on. How are we going to measure how rough or smooth the surfaces are? We're going to call that the coefficient of friction. We're going to write it with the Greek letter mu. Say mu. Start with a tail below the line. Make a tail go up, then make the letter mu. That's mu. Mu is a numerical index of texture, rough or smooth. Now, we could say, let's see, rough, smooth, slippery on a scale of, on a scale of 1 to 10, where 1 is smooth and 10 is rough. How hard would you say this dirt road is? Or maybe 10 is too big. How about on a scale of 1 to 5? How slippery would you say a tile floor is? Which one? What shall we make up? Well, we can't really make up anything. We're bound to work in units of kilograms, meters, seconds, newtons. And it turns out that the coefficient of friction in the real world is measured not on a scale of 1 to 5, but on a scale of 1 to 2. For instance, the Chicago Blackout's cold steel on ice. That's a surface we typically associate with negligible friction, practically no friction. How slippery is practically no friction, negligible friction? About a scale of 0.01 on a scale of 1 to 2. Somewhat rougher tires on asphalt would associate with a coefficient of friction of about 0.8, where 1 would be getting into the rough territory of rubber on concrete. Sandpaper on wood is passing rough into positively scratchy. We're up to 1.7 already. By the time you get to 2 on a scale of 1 to 2, check your math. Anything past 2, you're past rough and scratchy into the land of sticky. If you're not in duct tape, walking on duct tape, sticky side up, better check your math. Look at your handout, coefficients of static and kinetic friction, for more coefficients of friction between different pairs of surfaces. Thanks to engineersedge.com for putting all these in a convenient table where students and engineers can find them. These values come from the laboratory. Later in this unit, you'll measure your own coefficients of friction between your sneakers and the tiles on the floor. There's only one way to do it, and that's measure it yourself or look up somebody else's measurement. Now let's put it all together. How to find kinetic friction, the force that slows you down, the force that prevents you from keeping to move. We need the support force, and we need how rough or smooth the surface is, now known as the coefficient of friction. Let's put them together. Support force is the normal force. Coefficient of kinetic friction, how smooth or rough the texture is. Put them together, we have the force of kinetic friction. Write down your formula, put a box around it. To-do list. Kinetic friction problems. First, ask, is the object moving? If it's not moving, it's not kinetic friction. But if it is moving, bust out your formula, find the force of friction. You're good to go. Example, letting go. Here we've got some people doing stroller aerobics in a park. Real popular sport for parents, the only way people can work out if they can't get to the gym. You're pushing the stroller, but then you let go. On a sidewalk where the coefficient of kinetic friction is 0.89. Find the stroller's acceleration as it rolls away. What will it do? Newton's second law there. First step, you've got to make what? Then you have to find the what, and only when you're done with those two, find the acceleration. Do the full 3-step problem, pause the video, and press play to check your work. Are you done? You sure? Units, direction, check your free body diagram, check your net force. Is it negative? Good. In that case, if you're getting an acceleration of about negative 8.7 meters per second squared, you're in good shape. Negative acceleration means the stroller's going to slow down. Well, that makes sense because you're letting go of it. Let go of a moving stroller and it will slow down fairly quickly.